Hi all. So today we will talk about question 8.28, board and cylinders. This question is basically about a board of mass m lying on two uniform cylinders. And these two cylinders also lie on a slope, and they are rolling down the slope. And the question is asking us for the acceleration of the board, and it asks us to use the method of conservation of energy. So now let's try to analyze this. Well, what do we know? Well, we know that the change in potential energy equals to the negative change in kinetic energy. So that means, so for however much the potential energy decreases, the kinetic energy increases by the same amount. So this is a conservation of energy. So now let's see. In this question, potential energy, there's only gravitational potential energy. And so now let's try to list out the formula. We know that delta U for gravitational is mg delta H. And so let's try to figure that out. So let's say the system is originally here, and then it falls down to here. And then let's call this distance from the center of mass of the board to this center of mass. We call this distance d, representing displacement. And let's say that 0 point is here. Here is y equals to 0. And then obviously then d must be negative because the potential energy decreases. And so now obviously for the board, we have changing potential energy for the board is mg d sine theta. Why the sine? Because we have theta here, and this delta H stands for the change in the vertical displacement. And so if we construct a triangle here, we know that this is theta 2 by geometry. And so to get this height, we have d sine theta. And so this is the changing potential energy of the board. And let's say, what is the changing potential energy for one cylinder? Well, the cylinder doesn't displace by d. Why? Well, because say we have the system here. The board contacts two cylinders, one here and one here. So for every d, let's say every x, just to be careful of notation. For every x, the cylinder moves. This cylinder also moves x. And so adding together, we get 2x. So that we can list out the formula that the displacement of the cylinder of two cylinders is the displacement of the board. And so we know that the displacement of the board must be half the displacement of the board must be the displacement of the cylinder. And here we assume that the board equals to d. And so then by this formula, we know that the displacement of the cylinder is half that distance. Only so because just to explain it again, if one cylinder moves half d, we have two cylinders, and both cylinders move by half d, and together they make the board move by d. And so for the changing potential energy of one cylinder, we have mg half d sine theta. And so now let's write out the left side of the formula that delta U is the negative change of kinetic energy. So the energy that the system lost, the potential energy that the system lost, is mg d sine theta plus 2, because there are two cylinders, times mg half d sine theta. And then we know it's actually 2 times half m times g d over 2 sine theta, because the mass of the cylinder is m over 2. And so now we have mg d sine theta plus half mg d sine theta. And so we have 3 over 2 mg d sine theta. And so now let's try to list out the right side of the formula, the change in kinetic energy. And so first let's consider the velocity of the cylinder is not equal to the board. The translational velocity of the cylinder is different from the board, because if we take the derivative with respect to time, we get 2v cylinder equals to v board. And so we know that v cylinder is half the velocity of the board. Okay, so now we have that. Now let's just write out the changing kinetic energy of the board plus the cylinders. 2 cylinders. And be careful, because the cylinders are rolling without slipping, we can actually it actually consists of 2 terms. One is the changing translational kinetic energy, and the other is rotational. And then whole thing, we plus them, and then whole thing times 2. And so let's try to do that. Well, we have 3/2 mg d sine theta on the left, just as usual. And on the right side, the kinetic energy of the board should be just simple, half mv squared. And then for the translational term, we have, so let's write the 2 times because there are 2 cylinders. So 2 times translational term should be half times the mass of 1 cylinder, which is m/2, times the velocity of the cylinder squared, which is v/2, whole thing squared. And what about the rotational energy? Then the rotational energy should be half times I. We have I as half mr squared, but here m is m/2, so it's half. So this is half I omega squared. So this half corresponds to this half, and then I should be half times m/2 times r squared. So this corresponds to this, and then omega corresponds to v/2 over r squared. Why v/2? Because we just said that v cylinder is half the velocity of the board, and since we said that the velocity of the board is v, the velocity of the cylinder must be v/2. And so now let's expand. So 3/2 mg d sine theta equals to half mv squared plus, so this and this cancels, so we have 4 times 8, so 1/8 mv squared, plus this is 2 times 2 is 4, 4 times 2 is 8, 8 times 4 is 32, so 1/32 times 2 is 1/16 mv squared, and this r squared cancels, so this cancels. And so now we have 3/2 mg d sine theta equals to, if we plus these together, we get 16/8 plus 16/2 plus 16/1 mv squared, which is 11/16 mv squared. And so now we can cancel out the m. We have v equals to 3/2 times 16/11 times g d sine theta, and then 1, 8, so it's 24/11 g d sine theta. This is v squared, and so v must be square root 24/11 g d sine theta. Now what? How do we find the acceleration? Well, the question definitely asks us to use conservation of energy for a reason, right? So let's consider, what sort of formula can link acceleration and velocity together? And keep in mind that this motion is a constant acceleration because gravity is constant here, and there are no other forces that contributes to this acceleration. And so then, why don't we use the formula for constant acceleration? V final squared minus v zero squared equals to 2ax. So x is the displacement, and then a is the acceleration. So then we know, so previously you said v0 should be 0. V0 is 0 in this case because we assumed that there was no initial velocity. And so we have vf equals to square root 2a delta x. And now let's correspond these two terms. Well, let's cancel out a 2 first. So then this should be v equals to square root 2 times 12/11 g d sine theta. Does this look familiar enough? D sine theta is the displacement, delta y, not delta x. And then we have this is the acceleration. And so a, acceleration, should be 12/11 times g. And that is our solution to this question. Thank you for watching.